So let's start with the question tournament. You are given an array of integers a1, a2 and so on up till an. A tournament is held with n players. Player I has strength a of I. Okay, while more than k players remain, two remaining players are chosen at random. Then chosen player with the lower strength is eliminated. If the chosen players have the same strength, one is eliminated at random. Given integers j, k, determine if there is any way for player j to be one of the last k remaining players. Okay. So basically in this question we are given an array of integers, right, and we have to choose two random indexes from that array unless and until k players are remaining in the array, right? K elements are present in the array, and out of those two selected elements we have to see if one element is of less value than the other, then we are going to delete it, it's going to be eliminated, and if they are equal then one of them would be eliminated, right? And that's how we are going to go on and on and on to calculate if the given player that is given j is going to survive till the last or not, right? Let's understand the question with the first test case. So the first test case we have here, the values of n, j and k are 5, 2 and 3. Okay, so the value of n, j, k here are 5, 2 and 3. Now we have the array as 3, 2, 4, 4, 1. Okay, so the second player is to be checked if it remains till the last or not, right? So the second player is going to be this as the first index, right? So basically let's choose two random integers, two random elements from the array, right? Let's choose this element and this element. Okay, as the strength of this player is less than 2, then we are going to eliminate it, right? Okay, so how many elements are remaining? There are 4 elements remaining. Earlier there were 5 elements, now it has come to 4, right? So we have to go on until we have left 3 elements, right? So let's see if there are 2 equal elements we select. Let's select these 2 players, then any of them can be eliminated. So let's eliminate this, right? Now how many elements are present? 3 elements are present, right? So we can see that there is a way of choosing elements from the array such that the second player stays till k elements are present in the array, right? So this was the first test case. Now how are we going to approach this problem? Now let's see 3, 2, 4, 4 and 1. Now if we see which is the greatest element in the array, it's 4, right? So all the elements that are less than 4 are going to be defeated, right? So we can defeat this, we can defeat this, right, and we can defeat this. Okay, and how many elements are there that can be defeated by this player? It's this. Okay, so we are going to approach this problem in this way. Like first we are going to check how many elements are defeated by the player that we have to check, right? So we are going to first see that this player can eliminate how many of the other players, right? So this can only eliminate the first player. Okay, Okay, now let's see. So when one is eliminated, our count of the players becomes from 5 to 4, right? Now let's see if any other player can be defeated by 2. So no, right? Now let's take the element that is the greatest and see how many elements it can defeat. Okay, so it can defeat this element, it can defeat this element, and it can also defeat this, but we are not going to defeat this because we have to make sure that this player stays at the last. Okay, so when this player defeats this player and this player, so we have only 2 players left, that is 2 and 4, right? And the players go from 4 to 2, right? So we only have to check up until k elements, right? So if there are more players defeated, right, and there is 2 left up until then we can ensure that 2 is going to be there until 3 elements are left, right? So let's see another test case to understand this a little bit better. This test case, we have n as 5, j as 4 and k as 1. So up until only one element is left in the array, we have to ensure that the player number 4 stays in the game or not. So which is the player number 4? First, second, third and fourth. This is the player number 4 that we have to ensure stays in the game or not, right? So we are going to see how many elements this player can defeat. Okay, and it so happens that the maximum element here is also this element. Okay, so let's check. So 5 defeats 2, right? So we've earlier had 5 elements, now we have 4 elements. Now it can defeat 4 also, we have 3 elements left. It can defeat 3 also, we have 2 elements left, and it can defeat 5 also, so we have 1 element left. So as the number of defeated players is equal to k, so we can ensure that player 4 stays in the game up until only one element is left here, right? So output is yes. Earlier in the above test case, we had players defeated up until the only left players were 2 players, that is the maximum valued player and the player which we were going to save, right? So in the end that would only happen that only 2 of the players remain, that is one is the maximum player and the other player which we can save till the last, right? Because at the last it is so going to happen that the maximum player is going to defeat this, right? So if the value of elements decreases or is equal to k, is less than k or is equal to k, we can ensure that the player is going to be saved, right? Now let's see another test case. There is 1, 2, 3, 4, 5 and 6. We have n is equals to 6 and we have j is equals to 6, j is equals to 1, and we have k also equal to 1. So we have to defeat the elements up until only one element is left in the array, right? So let's see. The player we have to save is player number 1, that is this. Okay, let's see if this can defeat any player. So no, it cannot defeat any player because it is the least element. Okay, now let's see if how many elements can 6 defeat. So 6 can defeat this, right? So there were 6 elements, then it will get defeated. We will have 5 elements left. It will also get defeated by 6. We will have 4 elements. It will also get defeated by 6. We will have 3 elements. It will also get defeated by 6. We are going to have 2 elements. So at last only 1 and 6 are going to remain, right? So if only one element is left, then 6 will only remain at last. Okay, so if the value of players remains greater than k, so the value remaining at last is 2, right? And k is less than this value, right? So the output is going to be no. As if only one player is left, 6 is going to defeat 1 also, right? And only 6 is going to remain and 1 is not going to remain, right? So I hope you understood the process. Let's see the code for this question. Okay, so let's see this function. Solve. We have n, j and k. We enter n, j and k. We make a vector a which is going to store the elements of a, right? We have declared the index of maximum element as 0, right? We enter the elements and side by side we check if the maximum element index is correct or not. Keep on updating the maximum element index, right? Next we set count of players as n. So now we check this condition. If the maximum element is equal to the player that we are going to save, then we are going to set the maximum element as that player index. Okay, so that is because in this test case there were 2 maximum elements, right? And we had to save the 4th player. So if the 4th player is the maximum element, then it can defeat all other players, right? And if we set this, then this player and this player are going to be left in the end, right? That's why we made the greatest element as the player we are going to save, because the value of them are equal. Okay, so let's see, right? So we run a loop from I is equals to 0 to n. We check if I is equals to j minus 1 or I is equals to the maximum element. We continue because we have to save these players, right? Okay, now we check if the current element is less than the player that is going to be saved, or the current element is less than or equal to the maximum element to be saved. We decrease the count of the players, right? And at last, if that count is less than or equal to k, that means that the player is going to be saved up until that number of players, and we are going to output yes, else we are going to output no. If the value of count is number of remaining players is greater than k. Okay, so I hope you understood the approach of how to solve this question, and you also understood its code. If you have any doubts, you can write down in the comment section. Thank you.